Let's look at the fourth and the final question. An 1800 truck is moving at 12 meters per second towards an incline when the engine fails. The slope has 15 degrees upward angle with a height of 6.0 meters, and 8 degrees downward angle on the opposite side with a drop of 80 meters. Questions. A. Can a truck reach a hilltop by coasting? This is a hilltop. B. If yes, determine speed after descending. Obviously, this is a conservation of energy problem. For part A, it's asking you, can a truck reach a hilltop by coasting? Which means the initial state of energy, which is the car is like as soon as the car loses its engine, the energy it got is must be bigger than or equal to the energy it got at its final state. Well, actually, the energy it got when it reached the hilltop, EH here. Because if the energy initially is less than the energy car got on the hilltop, it'll actually slide down from the slope, which means it cannot reach a hilltop. So initially, what kind of energy the car has. Let's assume this is a ground level for part A. Initially, it is moving, right? So it definitely had kinetic energy, which is half times m times v squared. Is it attached to the spring? No. Is it above the ground level? No. So that's the energy at initial state. Then and the energy it requires to go on a hilltop is be the mass of the car, which is m times g, the gravitational constant, times h. So we can actually cancel m out. So it will be half v squared is equal to gh. So let's plug the number in. Half times velocity squared. Wait, hold on. I made a mistake. This one's supposed to be bigger than or greater to or equal to. This one is also greater than or equal to. Half times velocity squared is 12 squared. Is it bigger than or equal to 9.8 times 6? Half of 12 squared is 72. 9.8 times 6 is 58.8. So it's actually bigger, which means it can reach the hilltop without sliding down the slope, or it can actually reach the hilltop by coasting. Let's look at part B. If yes, determine its speed after descending. Well, for part B, we will actually assume this is a ground level. Part B is also about conservation of energy. So let's write it down. Initially, the car loses its engine when it's right about going up the slope, right? And it is equal to the final energy. So let's write it down. Initially, it's moving right, so it definitely got the kinetic energy, which is half times m times v squared. Also, be careful because this is not actually the ground level anymore, so it is actually above the ground. How much it is above the ground? So the car is over here, the ground level is over here, so it's actually 12 meters above the ground level. So plus m times g times h. And for the final stage, the car will be off the slope and it is moving forward. So it will only got kinetic energy. So it will be half times m times v1 squared because they're not the same v, right? We can actually cancel out the m. So it will be half v squared plus gh is equal to half times v1 squared. So now let's plug the number in. Half times initial speed is 144. You can use a calculator. 12 squared is equal to 144 plus 9.8 times its height, which is 12 meters above the ground. It's equal to, and it is equal to half times v1 squared. Well, let's actually use 10 here to make it easier because I don't actually have a calculator besides me. It will be 72 plus 120 is equal to half v1 squared. v1 squared is equal to 388, 384. V1 will be square root of 384. So it is around 19.59 meters per second. So that's the final answer.